So for this one, we want a sum, and you have to be able to spot ones like this. So it's an arithmetic series. It's an arithmetic series. You have to be able to tell if it's arithmetic or geometric. That's your very first thing you should do, right? After, because we've learned it. So now you have to go through and see. So if I go 3 minus 8, I get -5. If I go -2 minus 3, I get -5. So I know this is arithmetic, right? Now, if it's a sum, and I have the first and the last, an arithmetic sum, the first thing I'm going to have to always do is find n, no matter what. So if I have the first and the last of an arithmetic sequence and I'm asked to find the sum, the first thing I'm going to have to do is find n, and the only way I can do that is using the arithmetic formula. So Tn is -102 equals T1, which is 80, oh my gosh, 8, plus n minus 1, and then D is negative. So then we're going to subtract 8. -110 equals -5 times n minus 1. Divide by -5. 22, I believe. And then n equals 23. So that's the first thing we're always going to have to do. You will be given a test question, I promise you, where I'm going to give you an arithmetic series, first and last term, and you're going to have to find n. I promise. It will happen. It's not like, will it happen? No, it will. Like it's real. It's going to happen. Okay? So then we can use this first formula, which is Sn equals n, and we can use the first formula because we know T1 and Tn. So we're finding S23, and it equals 23 times 8 plus -102 divided by 2, and you get a 4-digit number. I can't remember what it is. I wrote it. 1081?
Yeah.
Now, it gets you actually -1081, right? But you can't put a negative into a numeric response. So if you get a negative question, a negative answer, be like, oh, I can't have that. Unless I actually ask for these lines around S, because this means the absolute value. Absolute value always turns whatever it is positive. So even though I have a negative number, I'm not freaking out because I'm asking you for the absolute value of -1081, which actually equals 1081. Okay? So be suspicious that if I give you an absolute value sign, your answer is probably negative. And I'm forcing it to be positive so it can go into the numeric response box. All right? This one I told you to turn to plus signs because minus signs would have made it negative, which is stupid. So this one I give you a sum of an arithmetic series and another sum of an arithmetic series. I'm going to have to do this always the same way. You will have one of these as well. So the first 5 terms of the arithmetic series is 85. The first 6 terms is 123. I make you fill them into the second sum formula and do elimination. Why? Because I need you to know elimination so that you can do later on a grade 11 stuff and a grade 12 unit as well. So if you had missed if you had been done distance learning 10C, that we're reviewing this. So we would do the formula Sn equals n divided by 2, 2t1 plus n minus 1d is the formula. I always put it in. Sn is 85, so I'm going to get 85 equals 85 divided by 2. And the t1 and the d always stay blank and stay what they are. Plus 85 minus 1d. 85 divided by 2 is 42.5? 85. No one's going to speak to me here? That should be a 5. Just let me roll with my 85, which makes no freaking sense. 5 divided by 2. And then 5 minus 1. There we go. So I get 85 because n is 5, right? Equals 2.5 bracket 2t1 plus 4d. And then I told you the very next thing you need to always do is divide this n divided by 2 over. So you get 34 equals 2t1 plus 4d. That's one of my equations, right? And then I do the next one. 123 equals 6 divided by 2, bracket 2t1 plus 6 minus 1d. So I get 123 equals 3, bracket 2t1 plus 5d. And then I have to divide by the 3. So it's going to be 41 equals 2t1 plus 5d. And then my next thing is to do elimination, right? So you have to be able to spot these types of questions. So we get the two equations, and then we have to do elimination. So we stack them. We go 34. I like writing them that last. So I'm going to go 2t1 plus 4d equals 34. 2t1 plus 5d equals 41. And then I subtract. I get negative d equals negative 7. So d equals positive 7. And then how do I get t1? Plug it back into either one of these. So I'm going to go 2t1 plus 5 times 7 equals 41. 2t1 equals 41 minus 35, which is 6. So t1 equals 3. And then I ask you for the first three terms. Well, once I have t1 and I have d, I can get the three terms, right? So my first term is 3. My next term is 7 more, so 10. My next term is 7 more, so 17. And then I want you to add them up. So 3 plus 10 plus 17 is 30. Numeric response boxes, you always fill in left to right, like you read. Left to right, like you read. The next one, I have the 15th term, not the sum. The 15th term in an arithmetic sequence is 43. So T15 equals 43. The sum of the first 15 terms is 120. Be suspicious when these are both 15. That means I gave you the sum and the last term, right? And if I give you the sum and the last term, I know I'm going to be able to use this first sum formula of arithmetic in order to figure things out. And it says determine the first three terms of this sequence. So I can go S15. S15 equals 15 divided by 2, T1 plus T15, right, technically? Or some of you wrote it like this, 15 in front divided by 2, same thing. Now S15 is 120 equals 15 bracket T1 and then T15 is 43 divided by 2 and multiply by 2. 240 equals 15 bracket T1 plus 43. And then we're going to divide by 15, which gets you a number. I don't know what that is. 16? Remember, if you're stuck, write what you do know and see if there's a formula on your formula sheet that is missing only one thing. Like you have all the rest and you're only missing one. So that's why I know I could use this formula, because I had S15, I had T15, I had N, and I was only missing T1. So at least I could solve for it, right? And then T1 equals negative 27. And then I can use the Tn formula. Tn equals T1 plus N minus 1D. I can do T15 equals T1, which is negative 27, plus 15 minus 1, and then D. But I can only be missing D. And they gave me T15, which is 43, equals negative 27 plus 14D. Add 27. 70 equals 14d. Divide by 14, and d equals 5. And then it wants the first three terms. So the first term is negative 27, and then I have add 5, so I get negative 22, and then I add 5, so I get negative 17. And then the bottom two are not the hard questions. Those are just your normal questions if I just ask you for a sum. They're not crazy hard or anything like that, but you still have to know what I'm asking for. So for number 4, it says determine the sum of an arithmetic sequence. Well, that means I have Sn equals n divided by 2, T1 plus Tn is an option, or Sn, oh, I always put 2 underneath, I forget. Sorry. Or we have n divided by 2, 2t1 plus n minus 1d. Those are our two options if I ask you for an arithmetic sum, right? So you have to use one or the other. And it all depends on what you have. You use the first one if you have the last term. You use the last one if you don't. Right? Narrows it down. So for A, I have the first term, the last term, and n. So then I'm going to use the one where I have the first and last term, right? So I'm going to do S10 equals 10 times negative 12 plus 51 divided by 2. So it's 10. What does that equal? I'm just going to write it. 195. So the sum of the first 10 terms is 195, right? Then this one, I don't know the last term, but I know T1 and D, so I can use the second one. So I'm going to find S14 equals 14 divided by 2, 2 times 42, plus 14 minus 1 times negative 5, and that equals 133. So these ones are the easier ones for sure, but you still have to know what the heck you're doing, or you don't know what formula to use, right? So the key thing is going to be determining the formulas. So I'm going to get you to open up your geometric sequences notes. Okay, so this one says determine the unknown terms in each geometric sequence, right? So geometric sequence means I have to use, I didn't print it to a smart notebook. See, it just stays on the board. There, that's fine. Has this been running the whole time? Awesome. Good. You're welcome. Extra information. They can fast forward. I don't even care. Geometric sequences. It's just part of the day. That's what I feel like. Okay. So geometric sequences only has one option. Tn equals T1 times R to the n minus 1. That's your only option you have, right? So this is very similar to the sequence questions we did, correct? With arithmetic, it's just a different formula. Okay? So ultimately, for this, we need to figure out R, correct? If we have R, we can multiply by it, done. That's it. So let's write what we do know. 18 is what? T1. And 6,174 is? Tn. What else do I know? N is 4. And then I'm missing R, which is good, because I can only be missing one thing. So Tn is 6,174. Just filling into my formula. equals T1, which is 18, times R, which we don't know. And then n minus 1 is 4 minus 1. So now we have 6,174 equals 18 times R to the 3. What am I going to have to do first?
Divide 18.
Yes. Divide 18. That was teamwork there, guys. Good job. What's 6,174 divided by 18? 6,174. Pardon? It's 300 and something. I don't know. Or maybe it's 30 something. I don't know. 343 equals R cubed. And then I have to take the cube root. Where the heck is that button? It's on your calculator. So what we can do is there's a square root button, there's a cube root button, but if there's anything bigger than cube root, you have to do it a specific way. So we're going to practice the cube root one that way anyways. So you're going to press 3 on your calculator. And then you're going to press math. So you're going to do 3, math, number. Five. It's the one with the X, right?
It's 7.
What? Yeah, it's 7. 3, math, number 5, and the answer is 7. Is what he's saying. Because you're going to pick the one that has that little X. Now, we could have just went math number 4 because it's the cube root, but anything higher than that, we'd have to go 3, math, 5, right? So my answer is 7. And now I can get the answer to the rest. So with geometric, how do I get to the next one when I have a ratio of 7? Multiply. So what's 18 times 7? What do we get? 126. And then what's that times 7?
882.
And then we're going to check. We're going to take 882 and times it by 7. And we should get 6,174. Okay? What's the catch with B, guys?
You don't know the first one.
You don't know the first one, so we're going to make a pretend T1. Remember how we did that with arithmetic? We're going to treat these like it's exactly the same as this one here with 4. We're going to find R, and then how do we go backwards? Divide. Yeah. So try it out. You're going to do this try and this try, so B and C. So we're going to use this as our T1, and this as our Tn, and we're going to use n as 4, right? So then we do Tn, which is 108, equals T1, which is 4, times R, we don't know, to the 4 minus 1. Divide by 4. 108 divided by 4 is? Equals R cubed. And then the cube root of 27 is? 3. So we're going to multiply when we go to the right, and we're going to divide when we go to the left, right? So 4 times 3 is? 12. Good answer. And then 12 times 3 is? 36. That was actually a good answer. And then 36 times 3 is? 108. So we know we're good, right? And then to work backwards, we're going to divide. So we go 4 divided by 3. And then we're like, stop there, because Lepp would rather have that than 1.3 with a decimal on top of it. We don't want that. Okay? We'll keep the fraction. And then C, we can use the whole thing. This is T1. This is Tn, or T5, whatever. And then n is 5. So we get 80 equals 5 times R to the 5 minus 1. Divide by 5. 80 divided by 5 is 5 into 8 is 1, and 3 and 0, 16. Equals R to the 4. And then we take the 4th root of it. So we do 4 math 5, which is times with roo. 2. My first word that came to mind was poo.
That's what I can.
Bit of a problem. Okay, times by 2. 5 times 2 is? 10. 10 times 2 is? 20 times 2 is? 40 times 2 is? And then that's when you rejoice because it actually worked out. The numbers match. And you're like, yes, I'm not done. That's how I roll. I don't know about you people. But when it lines up, I'm like, oh yeah, I got this. I'm so smart. And then when it doesn't line up, I'm like, what happened? It's usually typing something in my calculator wrong. All right, let's look at these bad boys. It's not really bad at all. Oh no. Okay, here it just wants you to determine the number of terms. So you remember how we used that, we made them be common bases of 2, and then we could just say the exponents must equal? That was for this moment in time, you know? Here it is. All right, so we want to determine the number of terms in a geometric sequence. Great thing about geometric sequence, one formula. Tn equals T1 times r to the n minus 1. You don't even have options, literally. That's it. When you don't have options, life is so much better because you don't have choices. So we know T1 is 4. We know Tn. How do we get r? Yes. Which one? 12 by 4. So we do 12 divided by 4. It should equal 36 divided by 12, right? These should all be the same. 12 divided by 4 and 36 divided by 12 is 3, or 3 en anglais. Okay. So we want to solve for n. So Tn is 78,732 equals T1, which is 4. R is 3 to the n minus 1. So this looks very similar to that stuff we were doing yesterday, right? So what did I tell you the next step is, David? You're right. You divide because you can't put those together.
Yeah.
Yeah. I told you knew the answer. Divide by 4. What's 78,732 divided by 4? 183. I'm suspicious.
I think you are suspicious. Yeah, you are suspicious.
Yeah. What is it? 78,732.
I don't know what to do. That's not the right number.
Oh, I don't like seeing that. That scarred me from my grade 3 or whatever. So bad at that. And then it always turns out
18,683?
Wasn't there like an acronym that we had to remember to like how to do it?
An acronym?
What do you call
Don't you
that
put like
one
an
where
R if
it's
it's
like
continuous or whatever?
a what?
A remainder?
No, that's for the other thing.
Did anyone divide it out and get 18,683?
It's 19.
It's 19?
Yeah.
Oh yeah, I said 9. Remember, see, it was an 8, and then I switched to 9 because I realized it could fit 36 instead of 32, and then that looks like a smushy 8.
I love calculators.
I love Lamp. Have you not watched, oh. Oh, it's like they pretend they're back in the 70s as Will Ferrell, and he's like, I love this, and the guy goes, I love Lamp. Oh, Anchorman! Thank you. Watch it if you haven't. Hilarious. I love Lamp.
I'd be watching that right now if I wasn't at school.
Okay, good one. 3 to the power of what is 19,683? And go. 3 to the, I would not do like 4. It's going to be a bigger number. Like, is it 9? He just totally guessed that. He was so proud of himself. He didn't even know, like, your look on your face was like, I can't believe
It's
that
just
just
one of
happened.
those days.
There's a calculator like stuck in the back of his eyes.
And then add 1. So n equals 10. Okay, you guys are trying B and C, and go. So for this one, we're going to have negative 1,458 equals negative 2 times negative 3 to the n minus 1. divide by -2. And what do you get?
729.
Now, a negative number becomes positive when it's raised to an even exponent. A negative number stays negative when it's raised to an odd exponent, right? So I know that even though these don't match right now, I can make this one be base -3 to something, and it'll become positive 729 if this something is even. So that's a hint. So I know it's going to be 2, 4, 6, 8, 10, something in there. Because the only way I can I need it to be a base -3, but I also need it to be a positive number.
So it turns into a positive if the exponent is even?
Yeah. And then it just stays negative. Because the reason why is if, say, it's, what is it, -3 to the 5? 6. It can't be 5. That would be wrong. So it's 6. Because you're going to go -3 to the 6 is the same as going -3 times -3 times -3 times -3. Right? And a negative times a negative is a positive, times a negative is a negative, times a negative is a positive, times a negative is a negative, times a negative is a positive. So every time you have an odd number of negatives, it's going to stay negative, right? And when you have an even number of negatives, it's going to stay positive. So that's why an even exponent makes them positive, and an odd exponent makes them negative. Grade 10, 101. You what?
I did the long way.
Yeah? Which works.
That's
So-
the right answer.
Yes,
That's all matters, right?
exactly. But it's good to understand why, because then you're not like second guessing yourself. And so then we have 6 equals n minus 1, add 1, n equals 7.
Let's go.
Then this one, we do 4,096 equals 4, and then 4 to the n minus 1, divide by 4, which is 1,000.
1024.
Yeah. I was trying to do log division in my head, it was hurting a little bit. Okay, and then 1,024 is 4 to the?
Fifth. Dude, I guess I would say
5 equals n minus 1, add 1, n equals 6.
Let's go. And we're done.
I'm actually going to quit first, because I'm going to be nice. So your homework, you should be able to finish in class, and the poor souls at home will be able to start watching the podcast after this. All right.
Losers.
That's not true.
Okay, are we recording? Oh.
Okay, so it's page 39, numbers 4 to 6.